And then when we convert that velocity, 1/2 mv square, when we convert that velocity, and we came to derive an expression, and we came to the expression where the total energy of a satellite will be minus GMME divided by 2R, right? 2R, because that V square will bring 1R minus, right? 1/2 will be like half of that thing, right? And then minus GMM by 1R, and that's how you get 2R. Okay, so let me move next something called Kepler's law. I'll Kepler's law. I'll go only briefly the Kepler's law. Right? Kepler's have 3 laws. The first one is, as we discussed last time, the planet rotates around the sun, or any planet rotates around the star in elliptical path, right? An elliptical path where the star will be in one of the focus, right? In any ellipse, it has 2 focus, right? Is that right? 2 focus. So basically, the planet rotates in an elliptical path where the sun or the star will be at one of the focus, other one will be empty, right? There will be nothing. Right? So that is the Kepler's first law. The Kepler's second law is the time rate dA by dt is constant. What it means is the area. Let's say the planet is here. All right. Let's say planet. What this leaves is, I'm not going to derive this. Okay. All right. I'm not going to derive. I'll just explain what this is. So let's say in a week, this planet moves from here to here. Okay. So in a week, if this planet moves from there to there, it means the area it makes at the focus or at the star will be this. All right. Now the question here is, in 1 week, if this planet is here, the area swept at 1 week will be something like this, because this area and this area will be same. Okay. And the area swept when the planet is here in 1 week, it travels only small distance, so that the area is long, right? Long means it will be narrow. It's a little bit narrow, okay? So the planet moves from this point to this point. So if you look at this area, will always be same. So what that means is, if the planet is closer to the sun, the velocity will be faster, because the same 1 week, this goes from this point to this point. Look, long distance, right? Right? So in long distance means in the same time it moves more distance, means the velocity will be more, isn't it? Yeah. It's fast. But here, this goes like this much mile, and this goes only this much mile. Make sense? So what it means is, at the same time, your area swept will be same. That leads to another important information is the velocity will be higher if it is closer to the focus, all right, or closer to the sun, in other words, right? And it moves slower if it is far from the sun. Okay, so it goes like this. So if you have sun here, the planet here, right? So slowly it goes like this, like slowly, and then slow. Are you following? Makes sense. So fast here, the area swept at the center remains constant throughout its motion. Alright? That's the Kepler's second law. And the Kepler's third law is the time period of the planet, means when it makes one round, the time period is proportional to 3/2 of the semi-major axis. What it means is semi-major axis is, by the way, let me go back. The time period of a satellite, do you go back to time period of satellite? In case of time period of a satellite, it was what? 2 pi r 3/2 divided by square root of the mass of the Earth, right? Something like this, isn't it? Right? Same thing, because planet is also like a satellite for the sun, isn't it? Right? Planet is like a satellite for the sun, just like moon is the satellite for the earth. So the formula will be more or less same, but the problem here is this is R, this perfect circle, isn't it? Well, technically a little bit elliptical, but anyways, circle. Here is elliptical. So semi-major axis is in any ellipse. If this ellipse, semi-major axis means this is your major axis. This is minor axis. All right. This one is called major axis. This one is called minor axis. Okay. Semi means half of the major axis, means from here to there. It is like a radius. It's like a radius, but in case of ellipse is this. So basically, the formula for the planet rotating around the sun will be, I'm not going to derive, but this actually it will be T equals to same thing, 2 pi, but in place of R you have 8 and 3/2 divided by square root of G, and E will be what? Mass of the sun or the star. Both has S initial, right? So whether that S is sun or star is the same thing. Make sense? So that this will be the time period of. So in other words, time period is proportional to 3/2 of the semi-major axis. That's Kepler's third law. I don't want to derive those things. I'll just stop here. All right, stop here, and let me do a few problems. All right, from the exercise.
Okay.
And I would like to, that's what most of you want anyway. Right? Bottom line is the problem, isn't it? But you need to know the conceptual understanding before you do any problems. If you understand conceptually all those things what I explained in the last class and this one, right? Then you can solve any problem. Okay? Okay? I'll do it fast. I want you guys to press your calculator really fast because you are the one who will be doing the problem. I'll just write the numbers there. Alright? So make sure you do your calculation very fast. Let me pick 13.6 at page 425. 13.6. What the question says is find the maximum direction of the net gravitational force of mass A due to B and C. There's a diagram there on A. You have one mass there, and one mass there. Alright? A, C, and B. This one is A, this one is C, and this one is B. Alright? So the question says mass A due to B and C. Each mass is 2 kg. So each mass is 2 kg. Mass of A, I'll write it. Mass of A is 2 kg. Mass of C is also 2 kg. This one is also 2 kg. Alright? If mass is 2 kg, one is a 10 centimeter and this one is 40. Okay, this one is 10 centimeter from here to here. 10 centimeter. This one is 40 centimeter. Now the question says find the maximum direction of the net gravitational force on mass A. Where is A? Mass A on this one. Alright?
Find what? Sorry.
Say again?
Find what?
Find the force.
Okay.
Net force on this mass. This is much easier than the problem that I did last time. Remember last time one mass was here, one was there, and one was there. 3, 4, 5. Can you remember this? Right? So you calculate F1 and then you calculate F2 and then all you do is just figure the component and do. But this one is so easy that excuse me. AC, this will be FAC will pull here, right? Right? I call it F1, which is FAC. Isn't it? So F of AC. Alright? All you do is just calculate this. Calculate this, plug the numbers, do your own math. Remember, F1 and F2 are on the same direction, right? Right? So your F net is what? What is your F net?
FAC plus F.
Exactly, very good. So this is very easy because F net, calculate the net force. F net is FAC plus FAB, right? Since they are both in the same direction, you can just add these two. You're done. What about part B? Part B is C, A, and B. It has like first here C, and then A, and then B. This is C, this is A, and then B. You are asked to find the force at point A. Alright? Force at point A. Now here's the problem. Now this is your point, right?
Same mass.
Same mass. So everything same.
Okay.
This is also 1, this is also 10 centimeter, this is 0.1 meter, right? This is 0.4 meter. Right? Now, when you get F1, because this guy will pull A on this side, because now this is your point.
Oh.
And then this guy will pull on the other side, right? This guy will pull on the other side. So here, the interesting thing here is, force, just like AC, now force AC will be on this side, right? And force AB will be on this side. All you do the same thing. The formula will be F of AC equals to G mass of A mass of C divided by R of AC square, right? R of AC square. Plug all those numbers. You have 2, G is 6.67 times 10 to the negative 11. Use 2 RAC is 0.1 meter square. Find the force, right? And the other one is what? Now you have FAB. By the way, now this is only 0.4. This one was what? This one AB was 0.5, right? Because your point was here, your A is here. So what will be your F net? What is your F net now?
FAB minus
What is it?
FAB minus
F of? Which one is bigger?
AC.
This one will be bigger, right? Can you follow? So by the way, you can do this. You can do this. Yeah, you can have a negative value which shows it's on the left, isn't it? Right? So this one you FAB, this one FAC you put minus here because it's going on the left. You can put here minus and this one plus, and then you add it, means one will be minus here. All right, and you get the answer. So that's pretty simple. I hope this hint is enough for you to solve the problem, right? 13.8. What the question says is, listen question first. Try to picture the question and then we'll solve the problem, okay? An 8 kilogram point mass and 12 kilogram point mass are held in a place 50 centimeter apart. You have 8 kilogram, 12 kilogram, they are at, what was it? 50 centimeter apart. So 50 centimeter, I write here 0.5 meter. Alright? The question says 50 centimeter, I wrote 0.5 meter.
Professor, what page is that?
That is 425.
Come on, Professor.
425. 425.
Alright.
No Spanish.
That's 76.
The distance between the two is 0.5.
It's 26.
50, 50. Yes. 50 centimeter. 50 centimeter is 0.5 meter. Okay. 50 centimeter. Okay. You don't like
I
this?
just want to make sure.
Okay, 50 centimeter. Alright, that's what the question says. Okay. So now the question is, a particle of mass m is released from a point between the two masses, 20 centimeter from 8 kilogram mass. So you have a particle of mass m. There is another guy which is at 20 centimeter from 8 kilograms. So this is 50. So this side is 20, this side is 30. Okay. So you have a mass m. I don't know what mass that m is released, is placed here and then let it go. Now what happens is this guy will pull this side, this guy will pull that side, right? Right? Now, I don't know which one will win for now. Alright? I don't know which one will win. Because this is small but closer. This is big but quite far. Isn't it?
What is the distance? Sorry.
This 50 is from here to there.
Oh, no, okay.
But this one is 20 centimeters.
Okay, that
So
was my question.
the question says, this side is 20 centimeter from here to there. A particle of mass m is placed at 20 centimeter from 8 kilogram mass. All right. Now the question, if it is released there, the question says find the maximum direction of the acceleration of the particle. So when it releases there, what happens is this particles tend to go, isn't it, on one side, whichever wings, right? Right? So whichever way it goes there, so what will be the acceleration of this particle if it has mass m? Did you understand the question? So in order to get an acceleration, first you need, because it is mass, in order to get acceleration you need force. So what you do is find force. I put here, let's say, I want to use two forces. Let's say this force, I call it F1. Oops. F1. And the other side, I call it F2. Alright? So I want to find F1 and F2. So this side is F2. I don't know which one is greater. I just use like arbitrary the length of the arrow. Okay? So this one is, let's say, F2. So I want to find F1 first. What do you do to find F1? How will you find F1? Same formula. Okay, this one do it yourself. Okay, calculate it fast. So what is your F1?
G.
F1 equals to G.
M.
Let me write the numbers. G 6.67 times 10 to the negative 11. M1, which is 8. I'm not writing unit again. Alright? 8. What is M2? M, I don't know. Right? I don't know.
You don't know.
Divided by what square?
0.7.
0.2 square. Do it quick calculation. By the way, let me write here minus, because I check this side negative x as, you know, as negative, right? On your left side is as negative. Do a quick calculation and let me know. And next one is F2, which is my green, right? F2 is my green. So F2 equals to, what is it? Since it's going that side, I take it positive. Alright? So G, which is 6.67 times 10 to the negative 11 times M times 12 divided by the way, don't multiply this M because M will be M, right? Alright. So whatever, just do this.
0.5?
What is it?
No. 0.5.
Do it fast. And this one is what? 0.
Yeah, 5.
What is this?
30? 5.
0.3
Yeah.
square. Right? Because remember, if this is 20 centimeters, this will be 30 centimeters.
Yeah.
This total is 50.
Oh,
So this
so
side
it's
will be
50.
30 centimeters.
Yeah. I was just one of it. So for the first one I got minus 1.3.
How much did you get?
1.3.
Well, negative, I think.
Negative 1.3 times 10 to the
To the negative 8.
10 to the
8.
8 or negative 8?
Negative 8.
Negative 8.
Yeah.
Negative 8 Newton. M.
M.
There M also there. Alright? By the way, it looks like millinewton. It's not millinewton. Okay? M times Newton. M and the unit is Newton. Okay.
And then the second one is
Negative 8.
Second one is
8.89.
I know it's 8 is positive.
8.89. 8.89.
89.
Yes.
Times 10 to a negative
29 to a negative
Negative?
9. 9.
9. Okay. Negative 9. M Newton. Right?
Yes.
Now what happens? What's the total force? Which one is greater?
The one that goes to the left.
8.7.
The one, this is negative 9, this is negative 8. So this is greater, right? So of course, the beauty here is, even though mass is small, alright, mass small, but your radius will be what? Radius square. Say it again.
Minus 4.1.
Minus?
4.1.
Minus 4
1 time 10 times. Yeah, minus 9. Yeah.
negative 9?
Mm-hmm.
Okay. So now what happens is, this n times n. M is also there. Right?
Yeah.
But you are asked to find the acceleration. So it's beautiful. Acceleration is what? Force is mass times acceleration, right?
Mm-hmm.
So mass times acceleration is this guy. So mass goes down, will cancel.
Then you get that.
Right? Right? So this is your acceleration. Are you following? So this much Newton. So basically your acceleration is whatever it is, minus 4 point whatever meter per second square. 13.9 is pretty much similar. I'll just give you a clue. All right, 13.9. What the question says is a particle of mass 3m, 3 times m, is located 1 meter from a particle of mass m. So there are two of them. One is mass m, other one is mass 3m. They are located at 3 times m. M can be anything. If this is 10, then this is 30. If this is 100, then this is 300. Okay? One is m, other one is 3 times m. They are located at 1 meter. This distance is 1 meter. 1 meter apart. Where should you put a third mass m, capital M? Now there is another guy came. Where will you put the third mass m, a big M, so that the net gravitational force is exactly 0? So what it means is the force you need to put somewhere here. What you know is it has to be somewhere on this side. All right. Now this is big M. Where will you put big M? Since this is small mass, right? This big M must be closer to the small mass. Then only the force this side and this side will be, because this is big mass, right? Make sense? So big mass will have more force, but since the distance is more, right? So it can be balanced. Did you understand the question? So find this x. In other words, how far or where that M, capital M, need to be placed such that this will be 0. In other words, the force this guy pulling on that side will be same as the force that guy pulling on that side. So let me change this to, let's say I call this F1. I call this F1, the force between lowercase m and uppercase m, and what ink left? Blue, black. Okay. The black one is the force F2 on this side will be same, exactly same. That's why it is neutral, right? So F2. So now all you do is calculate F1 and F2 and equal them. Alright? So my F1 is what?
G.
F1 is G. I'll write it straight. 6.67. You pressure calculate fast. 6.67 10 to the negative 11 times. M1 is lowercase m. M2 is uppercase m. Divided by the distance between them is what?
X.
X is square. I don't know what X is. Alright? Now what about F2? What is F2? F2 is black. Okay, what is black? F2. I'll leave it like this. I don't care. What I do F2 is, well, I'm supposed to, well, there's no simplification there anyway. Okay. So F2 is what? Well, this is negative, right? Because this one is on the left side. It is negative. Right? And the other side is what? F2 equals to positive because it's on the right. 6.67 times 10 to the negative 11 times m and then 3n. Right? And 3n divided by what?
1 m minus
1
x.
minus, very good, yes, it is 1 minus x and then square. That's the clue. Alright? Now, simple algebra. The net force is what? F1 plus F2 will be 0. Isn't it? So this plus this is 0 or this equals to this. Negative, because minus goes on the right will be plus, right? So, to be this in equilibrium, your F1 plus F2 will be 0, or in other words, 1 goes on the right, this equals to this. So let me write it down. I'll write it down. 6.67 times 10 to the negative 11 times 3 times m and capital M, right? Divided by, what is it? 1 minus x squared, right? So far, equals to what I have here, this one, right? 6.67 times 10 to the negative 11 times lowercase m, uppercase m divided by x of square. The beauty here is these two guys will cancel, right? So now what I do, this guy will also cancel. This whole thing will cancel, right? So I have only 3 here. So if I do something called cross multiplication, you know cross multiplication, right? So that is 3 x square equals to 1 minus x square. You can do it in 2 ways, by the way.
Yeah.
Okay, you can just simplify this. 1 minus 2x plus x square, right? When you open the parenthesis, isn't it? Now this will be a quadratic equation, right? Because when you bring this x here, it will be 2x square plus 2x minus 1 equals to 0. This is a quadratic equation. Use the formula plus minus whatever, right? You can do that way. Find x, calculate x yourself. You'll have 2 values, one plus and one minus, right? Or one can be like less than 1, or then one can be like 4 or 5 or something, more than 1. The answer cannot be more than 1. Are you following? Because the total is 1, isn't it? So I believe the one will be more than 1, other one will be less than 1. Alright? So you can do this. It's easy. Or there's another way. Look here. 3x square. I'll leave it that what? 1 minus x and then square. Right? Right? What I can do is, I can do square root of 3 and then x and then square, right? Equals to 1 minus x and then square. Right? Can I cancel square? Yes, but you have to use plus and minus at least one side. Right? So what I write here is plus minus square root of 3x equals to 1 minus x. Right? What it means here is, if I pull this on the left, it will be 1 plus minus square root of 3 of x. I take the factor out. Equals to 1. So far okay? Now look at the beauty here. The x equals, well, this is a little easier, right? Now x equals to what? Your x equals to 1 over 1 plus minus square root of 3. Right? Which one will you think will be the right answer? Plus or minus? Plus. If you place minus, then denominator will be less than 1. Means dividing 1 with less than 1 will be more than 1. No. Are you following? That's why choose positive. So this is 1 by 1 plus square root of 3, and this will be your answer. Alright? Because here negative leads to 0.3. Negative leads to x greater than 1. Did you understand?
Yes.
So what was the answer?
0.366.
0.367. What is it? 0.367 meters. And that makes sense. Where do I erase? This side?
No, the other side.
Come on,
Professor,
take a picture.
that's what I'm doing. How you gonna use this? Is the second part. Do the first
Which
part.
You know what? If you are confused, just do this. That's it. Do this.
Professor, just let me start the picture.
This is just the mathematics. There's no physics here.
This is easy, Professor. We're good.
It's hard.
Yeah.
If you think this is hard, then you don't deserve to take physics with calculus. Just if the calculation is hard. Okay. Okay, I'll leave it there. 13.19. 13.19. What the question says, I'll read the question for you. A planet orbiting a distant star, listen here. A planet orbiting a distant star has a radius of 3.24 times 10 to the 6 meter. The escape speed for an object launched from this planet's surface is 7.65 times 10 to the 3rd meter per second. So what's given here is a planet orbiting a distant star. Planet has a radius of 3.4 times 10 to the 6. So this is the planet. This is the planet. Has the radius of, I call it R of the planet, is given. What is given? That's the question. 3.24 10 to the 6. Alright, let me bring it here. (3.24 times 10 to the 6 meter). Alright, this planet, and then at the escape speed of 7.65 10 to the third, I write here v escape. Escape speed is 7.65 times 10 third. 7.65 times 10 third meters per second. What does it mean? Isn't it? Right? So what you do is K1 plus U1 equals to K2 plus U2. Escape speed is right here, which is infinity, right? Which you have K1, K2 equals to 0, U2 also equals to 0. Is that right?
Yeah.
For this one, K1 is 1/2 mass times velocity escape squared plus U1 is what? Minus G M is mass of this guy and then mass of the planet. What is the mass of the planet? Is there? No there? Okay. Let's say mass of the planet NP, which we don't know. That's okay. And then divided by what? Radius of the planet. Right? So they are asking what? They are asking the acceleration to gravity G. So what is the condition for acceleration due to gravity G? What is it?
GMP.
Right. So mg, which is the force, isn't it? Mg, which is the force, is equal to G m mass of the planet, right? Divided by r of the planet square. Right? This is the condition. So the clue here is what? This is giving you what? I can replace this guy, except the RP, with this guy, right?
Sorry, I didn't get the condition. Can you explain that again?
Say it again.
I didn't get the condition.
No, the question says, what is the acceleration due to gravity of this mass m?
Oh, okay.
To find the acceleration due to gravity G.
Oh, okay.
Alright? So the condition is mg equals to the gravitational force between the two. Remember, we discussed that last time, right? This Newton's second law, this is Newton's law of gravitation. Right? Mg equals to this guy. So the clue here is, I don't need the mass of the planet because I can replace this. Right? So all I need is what? Remember here, this m will cancel because, right? Here also this will cancel. Right? So GMP by RP. So GMP by RP, one of them I'll take out and multiply here. Is that okay? If I multiply by RP both sides, one will cancel, right? So in other words, RP times G will be GMP divided by RP. Is that okay? Is that okay? Now this guy is this guy. Right? So now what I can do is, I can replace this guy. So let me copy this, which is 1/2 velocity escape. 1/2 velocity escape. Oops. So the condition here is same thing. For M1 also you use this. The centripetal force is provided by G M1 mass of the planet, right? Mass of the planet divided by what? R1 square, right? Fortunately one will cancel, right? Is that right? For the another planet, on this green planet, right? Green planet is what? M2 V2 square divided by R2 equals G M2 mass of the planet divided by R2 square. Actually, we don't even need the radius of the planet. How you solve this? What I would do is I'll just divide. You know, that's easier. Isn't it? So that you can cancel. If I divide, let me use black. If I divide these two equations, what happens? This guy will cancel. Right? This mass of the planet is gone. m1, m2, v square. What else is gone? This one and this guy will be gone, right? This m2 and m2 is gone, right? And then m1 and m1 is gone.
And R1?
No, I1 and the square is gone. R1 with the square is gone. 1 will be there, right?
Yeah.
Beautiful. So what is this? V1 square divided by V2 square, right? Equals to what's here? R1 is here, right? It's in the denominator. R1. So denominator of the denominator divided by R1, that goes up. So this will be R2. Right? All you need is only this thing. Only this much.
Okay.
You don't even need mass. Right? You don't even need mass. That's it. So now the question is, find this velocity V2, right? Where is your V2? V2 is here. So basically your V2, right? It comes 7332, right? That's your answer, by the way. I hope it is correct. I hope your calculation is right. All right. You're rather smart, I know. 13.52. What the question? Let me bring the question, okay? It's very hard for me to. Okay. It's a 3-star question, by the way. All right. This one is 3-star. What it says is a landing craft with mass of 12,500 kilograms is in circular orbit, 5.75 meter above the surface of a planet. You have a planet here, and what it says is a landing craft of 2,500 kilograms is in circular orbit. Okay, so there is a satellite or a landing craft, all right, which is in a circular orbit. This guy that has the mass of 12,500. This one has mass equals to 12,500 kilogram. That's what the question says. It's orbiting there in the circular orbit 5.75 times 10 to the 5 above the surface of the planet. Okay, so above the surface, not the radius. All right, this is your R, but only from here to here. All right, only the height is given there. Okay, so height equals to, you know what to do, right? So height equals to, what is it? 5.75 10 to the 5. 5.75 times 10 to the power 5 meters. All right, that's the height given. What else? The astronaut in the lander measures the diameter of the planet to be 9.6. Okay, the diameter of the planet is given. Diameter. All right. So diameter of the planet. Diameter of the planet. I write here little p. This is the mass of the planet. All right. The diameter of the planet is given. 9.6 10 to the 6. 9.6 times 10 to the 6 meter. And what more information is given is the period of the orbit is 5800 seconds. Okay, by the way, this one orbits in 5800 seconds. So time period is 5800 seconds. Oh, that was so fast, right? That period of the orbit is. The lander sets down at the north pole of the planet. What is the weight of this much kilogram astronaut as he steps on the? Okay, the astronaut now when it lands here, the mass of the astronaut. By the way, mass of the astronaut is not the mass of the satellite. Okay, all right. Mass of the astronaut is given. Mass of astronaut is given. What is it? 85.6 kilogram. 85.6 kilogram. This is the information that you have. All right. This is the information that you have. Since the diameter is given, you can get the radius, right?
Right.
You can get RP. All right. You can get your RP. So what is your RP? Half of this, right? Diameter of the planet divided by 2, which is 9.6 will be 2 times 4, 8.816. So times 10 to the 6 meter. Is that right?
Yep.
So you have the radius of the planet, and what else is there? So once you get the radius, you know this r. So your r is what? R of the planet plus 8. Right? So this also you get. So r of the planet is 4.8 times 10 to the 6 plus your 8 is what? 5.75 times 10 to the 5. Right? So do this math really quick. So 5. So if I make it 6, I need to make point here. So if I make point here, this will be what? If I make point here, this 5 will be 5, 7 will be 7, this 5 and 8 will be 13, 1, 5, 5 point, this thing 5 point times 10 to the 6. Is that right?
Yep.
Right? Okay, I did it manually. So you have almost every information there. Right? So what information you have is, you have n and you need what? Mass of the planet. Isn't it?
Yep.
Right? So the condition here is what? Look, the answer is your mass times gravity is gm me. By the way, this mass is mass of the astronaut. I write here A. This mass of astronaut and this mass is different. This is the mass of the spacecraft. All right. So mass of the astronaut is the m of the astronaut divided by radius of the planet square. Oops, m is planet. All right. Right. The problem we are missing is RP. Right. RP. MA will use the whole thing. MA is given there, isn't it? The weight equals to this, but MA is given there. You need MP. That's the problem. You don't know the mass of the planet. That's why there is a clue of this guy. So going back to the same formula, which is what? The formula for time period is what? 2 pi. Yeah, ultimately you'll get, when you do mv square over r and then gm by r square, and you simplify it, and your velocity you replace it by 2 pi r over time period, right? And you'll get what? You'll get square root of r and then another r, which will basically give 3/2 of r. So basically 2 pi r 3/2 divided by square root of g mass of the planet. Is that right? Okay? So from here, this g and mass of the planet, what you do is simply find this. So this will be what? G mass of the planet is, I'll take it on the left. So this will be 2 pi r 3/2 divided by t and then square. Right? Did you get this one? Yes, now this guy you replace it here, right? And you have all the information. So what you can do is, you can separately calculate this because you have the r there. R is this one. You can calculate this whole thing and plug it here. Right? Or what you can do is simply replace this W. So your W equals to now, let me go back to W. Your weight equals to G and MP. G and MP will give me this 2 pi. Well, let me do this. Let me simplify this one line. All right. So this will be what? 4 pi square r cube divided by t square. Is that right? Right. So now you replace this. Now your W equals to. This and this will give me this, which is 4 pi square r cube divided by t square, and then times ma is there, right? And then divided by rp. Rp square is there. So now we have all the information. All right. So you plug this 4 pi square. What is your R? 5.375 times. One of you start calculating, okay? Times 10 to the 6 what else? 4 pi square 10 to the 6. This is whole cube times ma is, what is mass? 85.6. 85.6 divided by t square. What is the time period? 5800 square times rp. What is rp? rp 4.8 times 10 to the 6, and then this one square. Can somebody calculate this for me really quick? You got the idea. By the way, if you don't want to deal with those, right? Wherever you get those values, you keep right here. You just calculate this. All right. Or if you want, if you don't know this MP, just calculate MP from here. Divide by G. You know the value of G, right? Are you following? It may be a little bit longer, but it's okay. All right. So that at least you get some number, and it will be a little easier for you just to plug this number there. Does it make sense? Bit fast. I'll be able to do one more problem by the time you.
That's enough for the.
No, one more. Last. Why? Fast.
Wait, I have 677.
677. Okay. 677 Newton. I trust you. You have been right so many times. So we have a rocket. All right. Of mass. Mass of the rocket is given 5 times 10 third. 5 times 10 third kilogram. All right. 5 times 10 third kilogram in the circular orbit of 7.2 times 10 to the 6. 7.2 times 10 to the 6. So this one, I call it R1 equals to 7.2 times 10 to the 6 meter. The rocket is here, all right, in the circular orbit at this height, all right, at this radius. Height, no, radius actually. It says radius. So in a circular orbit of radius, that one. So it means it is from the center. That's a good question, right? If it says height, then you have to add that. Okay. The rocket's engine fired for a period of time to increase that the radius to 8.80. So what happens is now the rocket fires in such a way that it increases its radius to, let me draw it somewhere here. Alright. Now this rocket goes to the radius of, radius of, this one is, I call it R2, which is equal to, what I meant to my pen, okay, which is what? 8.8 times 10 to the 6, right? So this is 8.8 times 10 to the 6 meter. My R2 is new R2. Mass is same, it fires here. Alright? Now what question says is, what is the change in rocket's kinetic energy? Alright? How will you calculate this? What is the change in kinetic energy? You need the kinetic energy here, right? To get the kinetic energy, you need the velocity, isn't it? Right?
Okay.
And then how will you calculate the velocity here? How will you calculate first of all kinetic energy? Okay, the question what it says is, this is your 1, this is your 2, right? This is 2. Find velocity 1. Say it again? Yes, the same formula, which is m v square over r and v1 square over r1, right? Equals to g m me divided by r1 square. Is that right? You have your mass of the earth. You know this guy. You know r1. You can calculate v1. Is that right? So get v1 really quick. Get v1. Give me the answer fast. Square root of g is what? 6.67 times 10 to the negative 11. What is the mass? Mass of the earth is what? 5.97 times 10 to the 24 divided by what? R1, what is it? R1 is 7.2 times 10 to the 6. Is that right?
Yes.
So get V1. Similarly get V2. Did you get this number?
V1, 7436.
V1 is 7436 meter per second. I trust you. What is your V2?
6726.
What is it?
6726.
6726 meter per second, right?
Yep.
So this V2, this goes from here to there, right? Now get K1. What is K1?
1 half m squared.
So K1 equals to 1/2 mass times V1 squared, right? You have the mass. Now it comes the value of this guy, right? So this one is what? K1 equals to this one, which is 1/2 of mass is what? 5 times 10 to the third kilogram. I'm not writing kilogram. V1 is 7436. 7436 is squared, right? Give me this answer really quick.
1.38 times 10 to the 11.
Times 10 to the 11 joule, right? Okay, what about K2? 1/2 same mass, V2 squared, use the same number, 1/2, 5 times 10 third, your V2, where is V2? V2 is 6726, 6726, right? Squared,
Yep. So that is 1.13 times
1.13 times
10 to the 11.
10 to the 11, 1.13 10 to the power 11 joule, right? So what is the change in kinetic energy? That's what it says.
1 minus 0.
Change in kinetic energy is what? K2 minus K1. Oops. K2 minus K1. What is K2? 1.13 times 10 to the 11 minus what is K1? Which is 1.38 times 10 to the 11. What is this answer? 3. This will be 5. 3. This will be 2. Right?
Yeah.
Minus, because this is greater.
Yeah.
2.5 10 to the, so 0.25 11. So 11 means if I move it 1 on the right, excuse me, this will be what? 12, right? 12 joule. Oops, not 12.
With 10?
10, yes. Right? Moving right, so it will be 10. So 2.5 times 10. So did you get this one? Did you understand this one? So all you have to do here is, here the bottom line. Bottom line here is, give V1 and V2. You have R1 and R2. So if you know the radius, you know the velocity. Isn't it? So once you get velocity, you know the kinetic energy. The question is, what is the difference in kinetic energy? That's what the question is asking you. What is the change in rocket's kinetic energy? That's what it is. Does the kinetic energy increase or decrease, by the way? Right? Right? Because it decreases. Why? Because the velocity decreases when it goes out. Right? So of course the kinetic energy decreases. The next one is, what it says is, what is the change in rocket's gravitational potential energy? Now here's the thing. What is the gravitational potential energy? Means what? What is U2 minus U1? Isn't it? Change in potential energy, delta U, is U2 minus U1. What is U2? What is U2? Minus G M M E divided by R. Right? R1. 2 means R2.
Yeah.
Right? Minus U1 is minus, which is plus G M M E divided by R1. Right? That is the potential energy. So change in potential energy, all you do is plug the number. Minus, well, this will be 6.67 times 10 to the negative 11 times. What is M? 5 times 10 to the, oops, 5 times 10 third times NE, which is what? 5.97 times 1024, right? And then divided by, what is it? R2. What is R2? R2, 8.8. 8.8 times 10. 6? 6. So, this is minus, and then plus. You know what? Why I'm doing this? Why I'm doing this? You know what? Let me do this.
That's hard.
Let me do this. Because this thing comes out, right?
Yeah.
Isn't it? So if this comes out, I can just multiply here. Alright? 1 over R1 minus 1 over R2, isn't it? Is that right? Why you going to do it twice? You can take the factor out. This is the same thing anyway, right? So, okay, R1 also I'll change it. What is R1? What was the R1? 7.2. 7.2 times 10 to the 6 minus, what is your R1? This, and what is your R2? 8.8 times 10 to the 6. Do the math. Do the math. Give me the answer really fast. First of all, start from here. That'll be easier. And whatever it is, and then multiply with these things.
Be 5.03
Say it again.
times 10 to the 10.
5.03 times 10 to the 10. I trust you. Okay? Positive or negative? Of course, it will be positive because it's plus, right?
Yes. The potential.
Because this R is small.
Right.
R1 is small. This is big. So this is small. This is big. Right? So minus is small, plus is big. So it will be positive anyway. So change in potential energy is positive. Alright? And the last question what it says is, how much work is done by the rocket engine in changing the orbital radius? How much work is done on changing the orbital radius? What it means? What it means is what? How much work is done means what? All you have to do is, you have all the information there. All you have to do is, what is the erasure? Okay, it's here. Well, I don't know what it is. All you have to do is, I'll use a black ink. So, how much work is done? So, at this point, you get K1 and U1 plus W other, you are pushing it, will be K2 plus U2, isn't it? Right? So, all you have to do is, just use the formula K1 plus U1 plus you do some work must be equals to K2 plus U2. That's it. Alright? By the way, you don't need to calculate K1 and do all those things again. You don't need to do this K1 and U1 and do all of them W other and then push it there. The easy thing is, since you know, what is it? K2 minus K1, you know it, right? So what I would do is, I will push this K1 on the right. So I have here K2 minus K1. K1 goes on the right, will be minus K1, right? This whole thing I have here. Are you following? Be a little smart, right? Don't calculate K1 separately, U1 separately, this, right? This, and then same thing here. Where is your potential energy? U2 minus U1, right? This is your U2. Keep this on the right. So your W other only left here. Push this on the right. Plus U2 minus U1. Is that right? So now you have this information, you have this information. That's it. So your W other will be, this whole thing is minus 2.5 times 10 to the 10 plus, what is U2 minus U1? 5.03 times 10 to the 10 joule. So this will be what? Will be same thing. 2.5 times 10 to the 10 joule. I know it immediately because what I said earlier was the amount, the energy it needs to push from here to there is kind of a kinetic energy, right? Make sense? Did you understand this one? So this is the amount of W other. This is the amount of work done when you fired it. It pushed it to go to the next orbit. Okay, so I would like to do one more problem, but we are running out of time today, which is a binary stars. It's a beautiful problem. Okay, we'll do it next time. If you have further questions, let me know. If not, I'll see you next week.
Do you have
Make sure you have it. It's too late.